Okay, as we do completing the square, or before we do completing the square, I wanted to solve this problem on the left to kind of show you why completing the square would be helpful. So if I'm solving this problem on the left where it says x plus 3 all squared equals 4, the first thing I would want to do is get rid of this squared by taking the square root of both sides. Okay, if I take the square root of both sides, I have to remember to do plus or minus. The square root undoes the squared, and I'm left with x plus 3. On this side I have plus or minus the square root of 4, which is actually 2. So in a sense, if I had something nice like this, some quantity squared, I could square root and get rid of that squared. And now I just have a linear equation down here. I have x plus 3. So I can subtract 3 from both sides, and I have x equals, now the way I like to write this is negative 3 plus or minus 2, like that. And I really have two solutions, so I should write them both. I have negative 3 plus 2, which is negative 1, and negative 3 minus 2, which is negative 5. So those would be my two solutions. Now I want my problems to look like that when I have a quadratic like this. So it's called completing the square. It's making a perfect square like this so that this work will be able to happen. So as I look at this problem, what I want to do is I want to take this x squared minus 4x, and then I want to take this plus 8 and subtract it, or add whatever you have to do, in this case subtract it, to get it on the other side. So I end up with a minus 8 over there. Now I want to create a perfect square. The way you create a perfect square is you take half of this term, this minus 4x, take half of this, and it's minus 2, and so you would get x minus 2 squared. But you can't just change it to that. You have to do it in a certain way. So what would have to be in this spot so that it actually would factor down to x minus 2 times x minus 2? Well, if I was multiplying that out, come down here, I would get my x squared, I would get my minus 2x, I would get another minus 2x, that's my minus 4x in the middle, and negative 2 times negative 2 would be plus 4. So x squared minus 4x plus 4. X squared minus 4x, I need a plus 4 here in order for that really to factor to this. I can't just add 4 to one side of an equation. If I add it to one side, I have to add it to the other. And so once I've factored that, I now have equals negative 4. Okay, now it looks like this problem over here. So I can solve this by square rooting both sides. When I square root both sides, I have to remember to put a plus or minus. Square rooting undoes the square, so I'm left with x minus 2 on this side. And on the right, I have plus or minus. The square root of 4 is 2, and I have a negative under there, so it's 2i. And lastly, to solve for x, I add 2 to both sides, and I get x equals 2 plus or minus 2i. I can't go any further because it's a complex number, so I just have to leave it like that. Okay, a couple more problems where you're completing a square that are a little bit tougher. This first one, x squared plus x, I'm going to put the 5 on the other side as minus 5. I need to kind of complete the square here. I know that this is going to be x plus half of this, which is 1. So half of it is 1/2 squared equals something. I have to pick the correct number in this spot so that this side really will factor to x plus 1/2 times x plus 1/2. So what is that number that has to go in that spot? Well, it's whatever 1/2 times 1/2 is. And 1/2 times 1/2 is 1/4. So I would have to have a plus 1/4 in this spot. I also need a plus 1/4 over here in this spot. So negative 5 plus 1/4 is negative 4 3/4. Okay, now I can square root both sides to undo the squared. So I square root both sides. I have to make this plus or minus. I'm left with x plus 1/2 equals plus or minus the square root of negative, and I'm thinking about writing this as in a different way, but maybe 4 times 4 is 16 plus 3 is 19 fourths. Well, I could square root the bottom and make that a little simpler, but I don't think it's going to help that much. Ultimately, I have to do minus 1/2 to both sides, and my answer would be x equals negative 1/2 plus or minus the square root of negative 19 fourths. If I come down, I could simplify this quite a bit more, but let's just do negative 1/2 plus or minus. There's a negative in there, so let's make it I times the square root of 19 fourths. Call that good. Okay, over on the right, it's even more complicated because there's a 2 in front of the x squared. So I'm going to still start by doing the same exact thing at the beginning, moving that 5 over to the right as negative 5. Okay, now the next thing that we need to do is we don't want this 2x squared. We need to factor the 2 out, and thankfully the 12 has a factor of 2 as well. So I'm going to factor that 2 out and be left with x squared plus 6x on the inside, because that's what you would multiply 2 by to get these terms up above. Okay, now I want to complete the square with the stuff on the inside here and figure out what I need to put on that spot. Well, I know I take half of this, so I've got 2 times x plus 3 squared. Now I have to figure out the number that would have to go in that spot to make sure that I've got plus 3. It would really factor to plus 3, x plus 3. And 3 times 3 is 9, so this number would have to be 9. Now we have to be careful because we think, oh, we added 9 to one side of the equation, we have to add it to the other. But we didn't really add 9. Because this 2 is really being multiplied by all these things, what we really added was 2 times 9, or 18. And if we add 18 to one side of an equation, we have to add 18 to the other side of the equation as well. So then we have to do negative 5 plus 18, which is 13, and bring that down. Now we can go ahead and finish off solving the rest of this problem. I'm going to divide both sides by 2, so I'm left with something squared on the left-hand side. And then I want to get rid of the squared, and I do that by square rooting both sides. Don't forget the plus or minus. That leaves me with x plus 3 on the left, and plus or minus the square root of 13 halves on the right. I'm going to subtract 3 from both sides, and my solution is x equals negative 3 plus or minus the square root of 13 halves. And let's call that my answer, since the square root of 13 halves is not going to work out nicely.